This is a video about my ongoing battle to keep our aging Icemaker going. It's an Icemaker that seems to be used in a very wide number of brand names of Frigidaire, Westinghouse, Kenmore, General Electric. They all seem to use a similar kind of a thing. In a previous video I had problems with the ice tray itself, and the most recent problem is that it's been not freezing the ice cubes properly, so it fills with water in the ice tray, but before the ice is properly frozen, while it's still water in the middle and just a layer of ice around the outside, it tips the cubes out, and they then spill water everywhere and generally cause chaos. So I think I might have found the problem, which I'll explain to you now. In another video I explained how to get this, which is the control unit, out of the Icemaker. It occurred to me that probably the problem might be something to do with the thermostat, in that it might be that if the thermostat's not working, then the Icemaker doesn't know when the ice is properly frozen. And so I tried out that theory, and I think that's probably right. In a previous video I showed you how to get this, which is the control unit, out of the Icemaker. It's not too hard. If you turn it over here, there's a thermostat here, and this butts up against the ice tray, and I think what it does is that it measures the temperature of the ice tray, and as long as the ice tray contains liquid water, it's clearly not well below freezing, and so it waits until the ice tray is down to, I believe, around minus 17 Fahrenheit, which is about minus 8 Celsius, and then when it reaches that temperature, this thermostat starts conducting and causes the unit to tip out the cubes and move on to the next cycle. So testing this, you don't need to open this up in order to get the thermostat out. It actually just pulls straight out. All you need to do is get a pair of long nose pliers or something just so you can get a grip, and then just wiggle it. It's just a press fit in. It has no screws or anything. And on the back you'll see there's two pins, and the pins are offset. They're not central, and it's actually easy to figure out which way it goes back in. If you look down there, you can see there's two slots, and these pins here go into those slots, and so it can only go one way around, which is just back in like that. As I understand it, the way this works is that the top line here is the part number 37TVB01. That's what I searched on to find a replacement. This bottom line indicates the temperature behavior of the thermostat. So the complexity of these thermostats is that they don't turn on and off at one temperature. They have a hysteresis. In other words, there's a 15 degree Fahrenheit range between when they turn off and on when the temperature is falling and rising. So to explain, if this thermometer is warm, sorry, I keep saying thermometer, if this thermostat is warm and it's cooling, it will stay off, that is open, until it hits 32 minus 15, which is 17 degrees Fahrenheit, about 8 degrees Celsius, sorry, minus 8 degrees Celsius. When it gets to minus 17, it will turn on. That is, it will close. If it is cold, it will stay on, that is, closed, until it hits 32 degrees Fahrenheit, about 0 degrees Celsius, and at that point it will turn off. So to test these, it's not good enough to stick them in ice water, because if in ice water it's only going to be about 30 degrees Fahrenheit and it will not turn on or off. What you need to do, I tested this one by putting in the freezer until it's very cold. Your freezer is going to be around minus 20 Celsius. I'm not sure what that is in Fahrenheit, but very cold. Take it out of the freezer very quickly. Put a multimeter across these pins, and what should happen is that it should be closed, that is on, as the temperature rises. When it hits 32 degrees Fahrenheit, 0 degrees Celsius, it should turn off. Now this one, which is my old one, did not do that. What it did instead was, in this range, it was on, but instead of being approximately hardly any resistance, sort of quarter of an ohm or something, it was still staying at 100 or 200 ohms, which is not good enough. So this one is a dud. I ordered a new one. I put it in the freezer last night, and the Icemaker now works. But what I want to do, just for fun really, is to now take this apart and see if I can see what's gone wrong inside. Well, I've got the cap off it. I ripped the steel off and got that open. Inside there's just a little, I don't know if you can see that, but it's a slightly concave little metal, no doubt bimetal disc, and which pops in and out. You probably can't see that, and which appears, I think, probably to push these contacts in here, up and down. I can't actually see anything wrong with it. I'm just going to bend this up, which will wreck it, but it's wrecked anyway. I wonder if maybe it's just dirty contacts. Yeah, having a look at that, the contacts in there are quite burnt and black, and I'd say that's been the problem. It's stopped contacting properly. Anyway, it doesn't really matter why it happened. The short point is, if you have the problem where your Icemaker is producing ice cubes that are not properly frozen, then have a look at the thermostat and replace that. You might well find that that's the issue.